Everyone, welcome to the Engineering Theatre at RailLive 2024. The first thing I want to say is thank you very much to Pandrel for supporting this stage. The first year we're doing this, I'm quite excited as a rail engineer that we get to have slightly chewier conversations than they have over in the Policy Theatre. You know, we can get into kind of the weeds of some of the technical stuff perhaps a bit more than they do. But also, I'm very pleased to say that this session is where we have Jamie Pogson from Pandrel joining us to talk about, well, it's a broad conversation about how do, you know, this is a plant and equipment and very much a supplier-led event. How do suppliers get ahead of the needs of the industry? It's a very complicated industry with a lot of complex needs that are constantly changing. You know, big picture items like climate change, but some of the smaller stuff like short-term political demands. How do suppliers navigate that? And so that's kind of what Jamie's going to join us to talk about, but also giving us a chance to have a proper look under the hood at what Pandrel have been up to in terms of R&D recently. I will freely admit that as a track engineer, I'm excited by this conversation, but we'll try and keep it kind of on the straight and narrow as best we can. So, the first question I have is, Jamie, firstly, tell us what you do. Tell us a little bit about the team and what your day-to-day looks like, and then we're going to kind of get into some of a bit of a slide deck and open the conversation that way.
Yeah, of course. So, hi everybody, I'm Jamie. I'm a research and development engineer at Pandrel. I've been working for the company for 11 long years now. It's the only place that I've ever worked, and I'm very much Pandrelized. Let's say that's what we like to say in the company. I'm working for the Sustainable Resilient Systems business unit of Pandrel because we don't just do fastening systems, we have a multitude of areas of kind of expertise. Work in a smallish R&D team, which is of course part of a much wider global picture in Pandrel. Yeah,
absolutely. So, you know, you were saying earlier that in total, the Pandrel kind of R&D team is about 40-ish, around that order of magnitude.
Yeah,
and then your team is actually much tighter than that, focusing on that picture of resilience. Yeah, so if we want to crack through into the first slide, actually, we can kind of get ourselves started. First thing I shall say, while the slide deck is progressing, we might have some technical issues, which means I get to pad. Firstly, apologies to everyone who's we've done a little bit of rejiggling thanks to Perda. So as I've said in every session so far, we've had a little bit of a change back and forth with some of the sessions. So what's printed on the material might well have changed. So apologies for that. Right, we can press this button. So yeah, go on. I'm pressing the green button, and we will hopefully there might be a bit of a delay. There we go. So we're going to talk. We're going to talk about undersleeper pads, Jamie.
Yes.
Let's get started. I mean, the big question, rightly, what is one of those? What is an undersleeper pad, and why is it important?
What is an undersleeper pad, and why it's important? Great question.
Here is a slide we've prepared.
Yeah, here is a slide that we've prepared. But so undersleeper pads, pretty much exactly what they say on the tin. They are a resilient pad, a resilient element that we place on the underside of a railway sleeper. In the railway, a lot of people are thinking about rail pads, but often it's overlooked about the need for actually cushioning and giving some resilience to the sleeper. So this is what an undersleeper pad kind of is.
So it's worth saying for people who perhaps don't know the ins and outs of the railway system is that the railway is a fully resilient system, and one of the things that gives it its immense carrying capacity and its immense success is the very low friction at the wheel, between the wheel and the rail. The reason we have low friction is because we can have a very small contact patch between the wheel and the rail, about the size of your thumbnail, and we achieve that by having a very carefully designed system from the rail down into the unaffected, unmade earth, and managing the interfaces between each bit of the system, which Pandrel absolutely are part of, a very well-known part of between the rail and whatever's below the rail, but perhaps less well-known is that there's a very important interface between the sleeper, the sleeper, and then the ballast or whatever happens to be under the sleeper, and this is how you're managing and, if you like, taking greater control of that interface.
Exactly, yes, exactly.
So, and do shout at me if I'm not moving my slides on quickly. So we talked about resilience and elasticity. Let's very briefly talk about what this looks like and materially.
Yeah, no problem. So we like to say that for the sleeper pads, there are actually two fundamental mechanisms of why they actually benefit the track and why they work, let's say. So the first point, as you just mentioned, is providing the elasticity to the track. If we provide some elasticity, that's going to reduce its stiffness and overall increase its elastic length, its working length. So it means that for kind of the same wheel loading, the same impulse, we'll have a much greater number of sleepers that are going to share this force.
So materially, what that means is you can run more traffic over a given stretch of railway without that railway wearing out.
Pretty much over a greater number of traffic, it's experiencing much less force than it would do, in effect, without the sleeper pads. So that's kind of the first mechanism on how these things are working. And then the second mechanism is an increase in the ballast contact area. So this, for me, is the most interesting part, because when we look at the underside of a railway sleeper and we look at the ballast stones, we have something that's very flat in the sleeper, well, supposed to be flat, and then we have the ballast stones, which are very sharp, very angular. Obviously, when these go together, it creates a lot of force. You have a lot of point loading, a lot of point contact. On kind of an unpadded track without a sleeper pad, the sleeper is only supported by around 4 to 8% of the ballast. It's basically nothing is supporting your train and your entire track. To me, it still blows my mind every day that the number is so low.
It's interesting to pick up, isn't it? So for a good way of thinking about this for everyone listening is, in the past when we had timber sleepers, actually the timber would indent and the ballast would essentially indent into the sleeper. So you'd form a really quite nice interlocking matrix that would that would lock your ballast in place, that would provide that elastic interaction and would massively increase your contact area.
Yep.
The trouble with timber sleepers is that they rot. They're not very heavy, so they're not very good at holding the track in place long term. They also don't last very long. So we moved into a position with much higher traffic, much higher axle loads of concrete sleepers. The downside being concrete is very stiff, very smooth, all the problems we talked about. So in a way, the under-sleeper pad is bringing us back to that position of the it's taking some of the benefits of the timber sleeper and bringing it to the concrete.
It's bringing the best of both worlds. Let's say. And with a lot of research that we've done, we've seen that the contact area between the ballast and the sleeper, in a typical padded case, will go up to around 30%. So it's a huge difference compared to the unpadded sleeper.
Absolutely.
Which, obviously, if you're increasing your elastic length, it means you're giving your sleeper less stress to begin with, and then that stress is then distributed over a much greater area within the sleeper locally.
And that's all about just getting much more life out of the track materials above the under-sleeper pad, so your sleepers and the rails, but also, as I'm sure we'll get into, the ballast, which is the very time-consuming thing to replace.
Exactly.
So if I click the clicker...
And kind of these are the key benefits that we have for installing the sleeper pads. So the critical one that we like to speak about the most, which is probably the most interesting to everybody here, is the reduction in maintenance efforts.
Yep.
Because of all these kind of fundamental systems that we were talking about, this leads to a much kinder loading on the track, and it means that you have to tamp less, grind less, the settlement is much better. The kind of track geometry is maintained for a much longer period, and it's just,
And the multitude of benefits come from that. And this is, while we're talking about quite a specific product here, it's worth saying that the reason of this session is that this is all analogous to lots of other products, lots of other tools, in that you identify an issue, perhaps something that we've lost, in this case, we've lost some of the benefits of timber sleepers, you pull those benefits forwards, you apply them, and you understand what those benefits look like. So, for example, lots of people here rightly talking about safety. If it's allowing you to have a railway that requires less maintenance, that means you've got less people interacting with the physical railway, which means the railway is safer. It means you've got less people travelling, which reduces travel carbon. It means you're doing less running less diggers, running less tampers, which means less carbon as well. Less track access required, so you've got a more viable railway in terms of capacity. All these benefits start stacking up. So if you think of under-sleeper pads in isolation, you get immediate benefits, but also as part of the bigger systemic picture, which Pandrel happened to tie in quite a bit of that picture. Nice. Get the old corporate sound there. As part of that bigger picture, suddenly the benefits start multiplying, and that's kind of what it's all about.
Yeah.
So, there's a few more things on there that you might want to talk about.
No, exactly, yeah. So the main benefit that we like to push is the reduction of the maintenance, of course, but then they actually have benefits when it comes to track design. So, for instance, one of the things that we can push with the under-sleeper pads is the ability to reduce the ballast layer thickness. Because ballast itself has a certain resilience, ballast has a stiffness. When we kind of reduce the thickness of that ballast, it makes the whole track stiffer. What we can do is, by introducing the sleeper pad, this brings that lost resilience back into the track. And of course, less ballast is good because, it's not the easiest material to come by in some parts of the world. And
my day job is often desperately trying to get my minimum ballast depths when I'm designing a railway line. So the ability to sort of have a bit more flexibility in what that looks like is enormously helpful through, old structures or on earthworks that are tunnels, for electrification clearance, all these things where suddenly there's a bit of we've got a bit of a tool here.
Yeah, we've done a lot of research and development into this in Europe, and there's a lot of countries that are like systematically putting USPs on bridges or in tunnels just so they can reduce that ballast depth.
And other things like, so if you've got, in the UK we have a lot of wrought iron structures that are perhaps getting knackered, frankly. The fact that you can reduce some of those peak dynamic forces that we referred to earlier allows your structure to also, so not just the track, but also the supporting structures. Similar with earthworks, where if you're getting hammered with heavier freight perhaps, intermodal freight going faster and increasing those dynamic loads, under-sleeper pads can also lessen those. So there are lots of these knock-on benefits.
Yeah, of course.
So I suppose, briefly, how do you quantify some of those benefits? Because understanding those benefits, well, firstly, allows you to understand that you've created the right product, but also allows you to justify the case for deploying them. So how do you start kind of understanding those benefits?
Yeah, this is always the tricky part, but a lot of the times it's through a lot of laboratory research, which we'll then take to a test track, and then we'll kind of liaise with the networks. We'll get their input. We'll ask them, okay, how often do you have to tamp? How often do you have to do this, et cetera, et cetera. Look, install our pads, and then tell us how often you have to tamp. And it's really kind of a feedback system that we use with the networks to quantify these benefits.
So relationships with the if you like, the client organisations,
yes, with the
infrastructure managers is really important. So to what extent does that relationship is at a kind of a higher level, or to what extent do you have conversations with the boots on the ballast? In the UK, the TMEs, the track maintenance engineers. Do you have both? How do those conversations look?
Yeah, I suppose it depends on the specific case. Sometimes, obviously, we'll be speaking to the track engineers about the day-to-day things, but if we have to look at a global picture where we have to do a lot more data analysis, then we'll be going a little bit kind of higher, and it's always quite a mixed thing with us. And it depends on the network. It depends whereabouts we are, it depends on the network. So there's a lot of variety, let's say, in this kind of feedback.
One of the things I'm conscious I'm derailing you somewhat, ironically, but I kind of want to talk about data a little bit more, because it's one of the things that's different now to perhaps in the past was the ability, not necessarily for us to collect the data, although that's also improved, but it's our ability to assess the data, to manage much larger amounts of data, and to compare data with other data. To what extent are you've been at Pandrol for 11 years? Has the change in the way data is collected and analysed, how does that look from your perspective? How's that changed what you do?
Yeah, I would say that obviously it's a lot quicker now than it used to be. We used to have a lot of manual measuring equipment where we'd have to go out, we'd have to read gauges, and we have to do everything manually now. We have the automatic systems, we have the lasers, we have a lot of these things that produce a huge amount of data, but we can process it much quicker than we would if it was all the analog measurements.
Are you finding that, so obviously an organisation like Network Rail has a huge amount of data that it collects.
Yeah.
In theory, that data is available through an open government license, but how that actually ends up manifesting can be more interesting. Not just for Network Rail, but for other organisations like Network Rail, how easy do you find it getting hold of that data? Often data that is either open or perhaps how do you find that data relationship?
Yeah, again, it really depends on the network. It really depends on whereabouts we are in the world, what kind of procedures are in place. If they, for instance, some parts of the world, some networks have never seen a sleeper pad before.
Yep.
So they're very interested in having this kind of research, so they're very open to share. Yeah. Some networks know a lot about sleeper pads, they already know exactly what they want, etc. And they can be a little more closed, let's say, in sharing the data, which is rightfully their intellectual property.
But it's about so it's about navigating
kind of
that.
And, yes. Trying to find the way to make it beneficial for both sides.
So would you say, broadly, you would say that it's good for there to be an openness about that kind of data, not just for Pandrol, not just for the operator, but for the broad railway? Do you think it's a good thing that we have an openness for that sort of data?
Absolutely, yeah. Absolutely.
Right.
Everybody's. So.
Yeah, I was going to say it benefits. I'm thinking of all the suppliers within the kind of the wider industry. I suppose access to the ability to go, to identify a problem requires some amount of data, big or small. So accessing that allows us to solve problems. Right. Let's get ourselves back on track, and I'll give you this so I can stop harassing. There's a few other things on here.
No problem. Yeah, there's just a few other points. So these are kind of the current market trends of the undersleeper pads. So. Their kind of conception many years ago, undersleeper pads were kind of installed like railway pads, like rail pads and like ballast mats. A lot of people and a lot of networks installed them to mitigate noise and vibration. Now that they've been installed for 10, 15, sometimes 20 years, many networks and many kind of permanent way owners are realizing that the benefits are not really to do with noise and vibration. but the main benefits are kind of the long-term behavior of the track.
Yep.
This is where they're getting their data on the maintenance introduction, etc.
So again, we talked about systemic benefits and the way these all interrelate, and it's a good indication of having that data, because you go, this is about noise and vibration, and all of a sudden, 10, 15, 20 years down the line, why is our ballast not knackered? Why have we had to tamp this less?
Yeah.
And this is, again, an opportunity. Again, the value of having open data is that not only does the infrastructure manager identify this, but suppliers like Pandrel can see this and go, well, okay, we kind of knew that, but we were selling you on this point. But actually, it does all this stuff as well, by the way.
Yeah.
So again, we've talked about understanding and learning those benefits. We talked about data and how to manage that data. Before we jump to the next slide, how do you and there are, I'm sure, a few different answers to this. How do you start those conversations on, we've got this idea, how easy is it for you to find the right person to talk? I'm asking a question which I know the answer to, which is it's difficult, but I'm sure we'll enlighten ourselves a bit on it. How easy is it to find the right person to speak to say, we've got an idea of a problem we think you have that we can solve with this? How easy are those, that first conversation, how easy is it to find the person to have it with?
Yeah, I guess it depends on how good the sales guy is.
Yeah, yes, yeah, that indeed.
But,
and obviously Pandrel's sales guy is excellent, of course.
Of course.
No. But in all seriousness, it's those networks. So in a way, at RailLive, it's building those networks, right?
Yeah, of course.
Building those networks of knowing who's the right person to speak to.
Exactly, knowing who's the right person to speak to, knowing kind of what would be interesting to that specific person, and just trying to, present a really, really strong case on our side, which of course we have for the sleeper pads.
I mean, yeah, Pandrel, I suppose, have the benefit of being very well established, very well known within the industry. Key component is a bit of a trite thing to say, but no, quite literally key component to the railway. So for other suppliers, maybe what words would you have on how to build some of those networks for some of the perhaps younger, newer suppliers who are coming in with a completely different, from a different angle, but probably facing some of the same challenges of, I've got a solution, but I'm not sure how to, I think I can solve this problem for you, but I don't know who to talk to. What would you say to them?
Yeah, I would say events like this are critical, trying to get your name out there and trying to speak to an audience, making kind of research papers, publishing the research papers, presenting in conferences. Of course, there are many, many global railway conferences that we can present in, and it's just trying to build the relationships that way. And of course, if your product is a solid product, it will get recognized.
Absolutely.
And that's it.
Yeah, that's very, very solid advice. So let's keep crunching through the slides. Otherwise, I'll run down our clock.
No, not a problem. Not a problem at all. Yeah, so this is kind of a bit of an overview of how Pandrel do under sleeper pads. There are obviously other companies that make the sleeper pads, but we have our own unique way in making the pads, let's say. So our pads are composed of two elements. We have a resilient element, which is the part of the pad that actually provides its stiffness and its resilience. This is made of recycled rubber, and this is where we kind of combat the sustainability aspect. So we have the resilient element, and then we have, on top of that, we have a bonding layer, which is a geotextile type material, which can be used to install the pads on fresh concrete once the sleepers are made.
Ah, interesting. Okay, yeah.
So instead of making a sleeper, then gluing on the pad, we actually install the pads at the time of the sleeper being created. So it's a much more kind of quick and continuous process.
So you're not really adding any time at all anywhere. So from a perspective of the really time-critical bit, which is on track at 3 a.m., those sleepers arrive exactly the same as any other sleeper.
They arrive fully padded. You can do anything that you do with them that you would with unpadded sleepers. You can use all the track machines, etc. And they will arrive to the site, fastenings, pad, everything ready to go.
I never like oversimplifying things, but in a way, to let people visualize this who might not quite be picturing what we're talking about here, if anyone's ever got one of those sorts of little sticky pads that has a foam side on one end that stops your cupboard, your unit from knocking into chipping the floor or whatever, it's kind of like that, right? It's the little rubber bit with then the epoxy sticky bit that you peel the thing off and stick on it. Kind of like that, but larger and somewhat more long-lived.
Yeah,
but that's kind of the analogy, right? It's a bit like that.
Yeah, exactly.
Just for anyone who's going, so what do these things look like? I suppose they're big, long strips that go underneath the sleeper.
Underneath the sleeper, yeah.
Rubber bit
you'll
the
never
ballast
see.
sticks into. You never see it.
Yeah.
As with most things on the railway, if it's working perfectly, no one ever notices.
This is kind of the argument that we have as well. It's that we show all of these arguments. We say, look, this is amazing. Fit this into your track, and you never ever see it, but it's working. We promise, and this is also one of the challenges.
Yeah, it's not quite as visually iconic as the old Pandrel clip.
Yeah, as a clip or a rail pad.
Absolutely an integral part of that system.
Exactly.
Okay, right. Let's keep pushing forwards.
Yeah. Then the next few slides are just a bit more detail about each of the layers. So the resilient layer, as I just mentioned, it's made of purely recycled rubber. This is bonded together by a very small percentage of a binder. We can tune this layer absolutely perfectly to achieve a very consistent stiffness, because a lot of the misconceptions are using recycled material, it's not stable, blah, 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 blah. No, it's quite the opposite, actually. We control this material probably more than a virgin material.
Really? That's
Yes.
very I think the questions might come back to recycled stuff, and I'm conscious of time, so I'm going to, without,
Yeah,
I want to ask questions, but let's keep crunching with that, and perhaps people will pick it up, because recycled material is really important, and a lot of other people are picking up that as how important it is from a carbon perspective.
Yeah.
So, but let's keep crunching for. We can perhaps come back to discussing that a bit more.
No worries.
Yeah.
And yeah, then the bonding layer, as I mentioned, it's our patented technology for bonding the pads to sleepers. It can be installed on fresh concrete, and kind of these pictures show what it looks like at a macro and a microscopic level. It's a very woven fiber which has a very high surface area. It almost looks kind of like the Velcro.
Yeah.
It's almost like that. Once it's embedded in the concrete, it provides an extremely strong bonding force, and it's only 0.4 millimeters thick. So it's kind of perfectly engineered to do the job without looking too fancy.
So for clarity on that, that's going onto wet concrete.
Wet concrete,
so
yes.
the concrete is soaking through that layer, kind of into that layer to provide that really high contact.
Exactly,
Absolutely
yes.
stick it on.
The concrete solidifies around the fibers, and that's what provides the bonding strength.
Fantastic. Okay. We will
let
jump
you-
on. No, I shall continue. It's okay. This is good. So we're bringing into the kind of the big picture stuff, which will nicely take us to the closing point. We have this challenge. So we have the challenge with net zero, which is we need more capacity on our railway, so we need the railway to run better, but also we need to minimise the embodied carbon, right? So what does that picture look like in terms of USPs and in terms of the development process for them as well?
Yeah, of course. Well, as we've just been talking about, the Pandrol USPs are made from a recycled rubber material, which is, in terms of CO2 footprint, we're looking at around 3 to 4 times less carbon accounted for producing that than a virgin material in, say, a plastic material.
Yep.
So already we're kind of ahead of the curve when it comes to that. And then because when the pads are installed, we have much less maintenance operations, we have a reduction in carbon indirectly from that aspect.
Yeah, it's fresh in my mind is the fact that the undersleeper pads add tens of percents extra onto ballast life,
Yep.
which means years of extra life. It cannot be overstated the extent to which USPs should be standard across the railway, and
Exactly.
it still isn't. We're not quite there yet as an industry, but absolutely, this is a classic example of a component that a full modern railway isn't kind of, or ballasted railway isn't kind of really complete without now.
Exactly. But when you look at a railway 50 years ago and you saw a rail pad, what's that?
Yeah.
Now,
Yeah.
if you see a
Ubiquitous.
railway without a rail pad, you think, that's crazy.
Yeah.
This is what's going to be the case with the sleeper pad. Now the benefits are realised. It's really a booming product.
Absolutely. So there's a little bit about talking about the recycled rubber, which we can pick up again if you want.
Yeah, of course. So the core material for the recycled rubber is coming from end-of-life tyres.
Okay. Yeah.
And a lot of people don't realise once a tyre has kind of reached the end of its usable life on the road, there's still a huge amount of rubber left on the tyre that's never seen a road and it's never been touched. So this is kind of the rubber that goes into our USPs. It gets shredded. We remove all of the steel and all of the banding, etc.
Yep.
And then we have these nice, lovely rubber granules.
So it's not only is the railway doing the right thing for its own internal sort of whole life loop of carbon, but also we're kind of almost pulling stuff out from other industries to help out with the carbon cycles.
And when you
there
look
as
at the amount of tyres that go to landfill, we are massively helping that situation by bringing them out of the landfill and putting them back into a usable and serviceable product.
Absolutely. So this is this is kind of a good slide that you've created here to bring back round some of the stuff we've already discussed, and I think probably to kind of reach us towards the point of wrapping up. We've talked about how you approach clients to understand their problems. We've talked about what that development looks like, but tell us a little bit about what the life, if you like, the life cycle of the development of these types of products are.
Yeah, of course. So as you mentioned, the first thing we'll do is kind of understand the market, understand what the market needs, understand if there's something that we can provide, something that we can develop. We can make a life cycle analysis on that product before it's even been created, to see how feasible this development is going to be, what's going to happen X years down the line. All of the USPs that we've developed, we've had third-party consultants look at the life cycle as well. So we have fully certified EPDs, environmental product declarations, which will show exactly, the CO2 content for each stage of the development. If it's something new, we'd obviously have to do a lot of testing. So we'd have to do a lot of in-lab testing, sometimes test tracks, large-scale tests. and then we kind of bring that product to the market and say,
the best test is when it's run trains run over
yes.
it. You know, that's it.
Exactly.
Yeah, absolutely. And I suppose that again, widening this out to the bigger picture, that process looks similar for everyone, and getting each stage right and ensuring you learn the lessons at each stage is really critical, right?
Yeah, exactly.
So a little bit about, we've talked about whole life cycles and whole life costing. There's a little bit of detail here for people who want to get stuck into the numbers. But
yeah, a little bit of specific numbers for the USP. So this is a little bit about the life cycle costings of the USP. There's a really nice document, the IRS, which is kind of like a European document that's a guideline for the use of USP. And they've done a huge study, which we were involved in back in the day, on just USPs in general and their life cycle. And some of their main findings were that the initial track quality is 18% higher than without the USPs. So you're already starting with a much better state of track than you would without. The degradation of track geometry is reduced by over 60% within its lifetime. The tamping cycles can be prolonged by a nearly factor 3. So you'd almost have to tamp 3 times less, which I'm sure is music to a lot of these networks' ears. And the actual lifetime of the track can be extended by a factor 1.6.
Yeah.
And this was kind of done on a big global network with lots of networks in Europe. And these are kind of the main points of the life cycle of the USP.
Key thing to capture with this information is even not on the specifics, is this data is really important, so make sure that you build that case.
Yes.
and have a data-driven case to justify. You know, there can be problems in suppliers, particularly those from outside the rail industry, coming in, bringing a solution without necessarily identifying the problem that the solution solves.
Exactly.
Would you say that's what would you say to that approach? Would you say, no, you need to identify the problem first?
I think if there's no problem, there's no product.
Yeah.
Yep. You know, you have to bring something to the market that's going to benefit the market. You know, you could have something amazing, but if it doesn't solve any issues or any products, any problems, it's a
non-starter. Yeah. So the key thing is to understand that you have a problem-solving solution.
Yes.
It's getting that data. It's understanding here are the numbers that really justify and build that case.
Yeah, exactly.
And okay, we're talking about data. Usefully, this slide has appeared. I have no idea what the slides are, so I'm, as people might realise, I'm improvising. But this very nicely shows how you capture that data.
Yeah, so this is an internal calculation tool that we have for the life cycle costing of the sleeper pads. So this is something that we've captured, like you say, all the data from many networks, many projects. We built up a bit of a database, and then we're able to tune this tool. So if we have a new project, a new network, we can say, look, if you fit this specific sleeper pad, this is what you're going to see in return.
Very nice.
You'll get a payback in this many years. You'll see this much of a reduction in CO2.
So it's getting that data to make the case for the product, to really, so that the person who's going to be basically buying that product sees why they need to,
exactly.
what the reason for it
and
is.
it's completely tunable. You know, you can change the type of track, the design of the track, the ballast thickness, the soil. Everything is completely tunable on a case-by-case basis.
I mean, as a day job person, I will be speaking to you afterwards to go, what's the link to that? And how do I, what can we do to get the answers? So, so we got, here we are, end of slide, so we know where we're at now. Very briefly, because I do want to get a couple of questions in if possible. So,
yeah, of course.
Yeah, if you want to wrap up with a couple of points. And,
so the main conclusions that we'd like to say is that the addition of the USPs into the track are going to significantly increase its life, reduce the maintenance, provide a better environmental footprint of the track. We kind of go above and beyond and do a lot of research that's not required, but we like to do it because we like to know when we are always pushing for perfection and pushing for innovation. And kind of our USPs, because they're recycled, it offers a unique approach to this problem.
The USP for the USP.
Exactly.
I was waiting to make that gag
I was waiting
right the way through. Yeah, I resisted hard. Right. James, thank you so much. That was really, really interesting. We've touched on a lot of stuff there that's hopefully applicable for lots of different suppliers with lots of different backgrounds. Do we have any questions? Anyone get any thoughts, any queries? People are just thinking about USPs. Nigel? Ashley, we'll get a microphone to you before you... it's coming. Over this side, sorry, yeah. Pop your hand up, Nigel.
Yeah.
Yeah, it's standard, isn't it?
Thank you. Yep. I can see the advantage of the undersleeper pad for new track. If you're going to lay new track, the figures are there. Do the calculations. Is it worth putting in or not? If you've got track that already exists and doesn't have undersleeper pads, and the track's likely then to be there for 20 years or so, the cost of installing it would be high. but there also would be savings. So how do you weigh up whether it's worth tearing the track up and putting pads in, or is it really something that's only applicable to new installations?
That's a great question, to be honest. I think it depends whereabouts that track is within its life cycle. You know, if the track's already been laid for 10 or 15 years and you're seeing a lot of issues, then I would say, yes, it's probably beneficial to install the sleeper pads, because they can't just be installed on the fresh concrete. We can also glue them to pre-existing sleepers, for instance, but of course it's quite invasive to, you know, remove the ballast and take out the sleepers.
So it's one of those situations where, you know, if track's getting battered, the renewal cycle of that track is actually probably quite short.
Yep.
And so the value will be in coming back. You know, when we reinstate high output track renewals, please reinstate high output track renewals. When we have high output coming through, they will just have USPs fitted to all the sleepers they drop in. So yeah. You're right in that there is a bit of a potentially, where you have the benefit of potentially fitting USPs is where you have much longer life, lower trafficked railways, where actually there is a benefit to extending those materials by using an in situ applied USP.
It just,
Doing these things on, you can't just put them in while you're doing ballast cleaning, for example. You've actually got to have the sleeper out.
exactly, yes, the sleeper does have to be removed from the track, yes.
This is really for when you've got new or serviceable sleepers being put in as part. You wouldn't actively rip up the track to put these in specifically, but we do reuse sleepers. You know, we do reuse, you know, serviceable sleepers have a long life. So if you're pulling out, if the high output machine or whatever it happens to be is pulling out, you know, 10 kilometers of F27 BSs, those quite happily can have a pad stuck to the bottom of them. So yeah, there is an opportunity there, I think. But yeah, you wouldn't actively pull up the railway just to stick USPs in.
Yeah, it depends. If you have a lot of issues with that specific section, then I would say it'd probably be worthwhile.
Okay, yeah.
Definitely worthwhile. But again, we can use the tool to have a look on a case-by-case basis to see, okay, is it going to be advantageous? Is it not?
Fantastic. But the key emergence, I'll wrap up now because we've gone 2 minutes late, but I'm dreadful at that. Actually, 2 minutes is nothing for me. Anyway, the fact that I think a neat way to end is data, actually. It feels like a key part of that supplier journey is making sure that you're getting the data at the start to understand what problems there are, but you're also getting the data to understand what your product is achieving.
Yeah, exactly.
Perfect. Everyone. Another thank you to Jamie, and thank you to Pandrol more broadly for supporting the Engineering Theatre this year. Hopefully we'll see you in the next session, which will be starting shortly. Thank you so much. That's fantastic.
Thank you.
Cheers.